Hello everyone, welcome to the world of software testing. So in the last lecture, we have seen 4 values and 12 principles of the Agile methodology, which are described in the Agile manifesto. So hope you have watched all those previous lectures based upon Agile methodology. So if you did not watch them, please go to the playlist and watch all the videos based upon the Agile methodology concepts, which are very important in terms of interviews. So you should be prepared all those before going for the interviews. So in this lecture, we are going to discuss about the 7 principles of software testing and which need to be kept in mind while doing the software testing. So let's discuss one by one. So the first principle is start the software testing at very early stages, means from the beginning when you get the requirements. So this means the software test engineers need to get involved in the software development lifecycle at the very early phase to find out the defects during the requirement analysis phase, or any documentation defects can be identified. So the testers has to be involved in the starting phases such as the requirement analysis phase. So when they get the requirements from the product owner, the cost involved in the fixing such defects is very less when compared to those that are found during the later stages of testing. So the defect cost is very less in the early stages, but if we found any defect later stages such as production, maintenance, so it cost very high. So it's better to have the requirement clear, defect free, so that we are not going to so that we will not produce a defective product, and this will save our cost. So this is the start software testing at the early stages. The second principle is test the software in order to find the defects. So basically the software test engineer needs to be very clear with his intent to find out the defects from the software application which is under test. So if the software is tested fully and if no bug is found in the software application, we can say that the software is 99% defect free. We cannot say 100% defect free. But what if the software is tested against the wrong requirements? So if the requirements are wrong and we are testing the software against those requirements, so it's very difficult. So in such cases, even finding the defects and fixing them on time would not help, as the testing is performed on the wrong requirement, so which are not as per the needs of the end use. So such type of testing is of no use. The third principle is highly impossible to give the bug-free software to the customer. So even the software application goes into production after the successful execution of different types of testings, so which is done by the software test engineers, such as the integration testing, functional testings, non-functional testings, acceptance testing, and many more. So the component testing, system testings, so that will be done before the software goes to the production by the software test engineer. No one can say that the software application is 100% bug free, though the main objective of software testing is to find out the hidden uncovered defects in the software application. So there will be some percentage of bugs will remain in the application. So that's why highly impossible to give the bug-free application to the customer. The fourth principle is should not do the exhaustive testing, means we should not use the same type of data for testing the application every time. So if it is not possible to test all the functionalities with all valid and invalid combinations of input data during the actual testing practice, so instead of this approach based on the priority, the testing of the few combinations are considered during the different techniques which can help improve the test coverage. So the combination will be derived with the help of different techniques. So those techniques such as such as BVA, that is boundary value analysis technique, the ECP, equivalence class partitioning, and there are some few more techniques available to help improve the test coverage. So we'll discuss those in the upcoming lectures. The exhaustive testing will take the unlimited efforts, and most of those efforts are ineffective because also the project timelines will not allow the testing of so many number of combinations. Hence it is recommended to use the test input data using the different methods like the equivalence class partitioning and boundary analysis. So basically these type of techniques reduce the test case design, or we can say reduce the number of test cases to be executed, and parallelly achieves the good test coverage. The fifth principle of software testing is the testing is context based. So it means decide what type of testing should be conducted based upon the type of application. So there are various domains available in the market which undergo testing. For example, a banking application, the medical applications, the advertisement, social media applications, and many more domains are available in the market. So based upon the requirements, functions, different types of testing purpose, risk techniques of particular domain, there will be a different testing to be performed on those. So let's say, for example, in case of banking, the security is given a most priority. So the security testing must be done in case of banking application. So we should not skip the security testing in case of banking application. So for example, in case of social media applications or the government application, the websites, the performance testing should be performed, as there are a lot of users are going to use that applications or website. So you might have observed there is a performance issues with the government sites, as everyone is using the sites at the same time. So that's why the testing should be context based. Based upon the application, we should apply the types of testing to be executed on the application. The sixth principle is we should follow the concept of pesticide paradox. So if you are executing the same test cases, same tests are running from the longer run again and again, they won't find the defects for us. So basically what happens, we design some test cases at the start of the testing, and then we run all those test cases during the continuous releases. So if you try running those same cases or the test sets for all the releases, then they are not going to find any defects for us. So in order to avoid the pesticide paradox effect, we have to keep updating the test cases in each and every cycle releases in order to find more defects, and those test cases needs to be regularly reviewed and revised. So again, for example, in case of if there is a new feature comes in the application, so definitely we should add some of the new test cases related to that particular feature, and if that feature is affecting the other features as well, then again the whatever the current test cases are there, those should be reviewed and revised. So that's why we should follow the concept of pesticide paradox. Then the last, that is the seventh principle of software testing, is we should follow defect clustering, which is nothing but a Pareto principle. So during the software testing, it may happen that some of the modules contains most of the defect. So based upon the testing experience, or if you are testing the application since last maybe for example 5 to 6 or 10 releases, so you must understand what are those modules which contains most of the defects. So this may depend upon the various factors such as the complexity of the code, module, dependency of its on other. So if it is dependent upon the other application, so these are the factors for which the defects clustering works. So by experience, we can identify such risky modules by applying the Pareto principle, which states that the 80% of the problem are found in 20% of the module. So this is nothing but a principle, Pareto principle. So yeah, so these are the 7 principles of software testing. First one is the start of software testing at the early stages, means from the beginning when you get the requirements. Second one is test the software in order to find the defects. The third one is highly impossible to give the bug-free software to the customer. And fourth one is should not do exhaustive testing, means we should not use same type of data for testing every time. Next one is testing is context based, it should be, and we should follow the concept of pesticide paradox. And the last one is we should follow the defect clustering, that is the Pareto principle. So these are the 7 principles of software testing. So thanks for watching this video. Hope you have liked this video. Please do subscribe our YouTube channel for such more videos and click on the bell icon to get the latest updates. So in the upcoming lectures, we'll dig further into the software testing concepts. So stay tuned. Thank you so much.